Finally, we started with fiber. This week and the next week, we'll cover the basic concepts regarding fiber and transmission through fiber. We started with the ray picture. I hope that part was familiar to all of you. And then we just discussed briefly about the mechanisms with which attenuation in fiber happens. And then we went in depth into the fiber modes, starting with the ray picture and then solving Maxwell's equations, then these new concepts like these universal BV curves we went through, like and, effective indices of modes. So these were new concepts, I think. And then we capped off the week using this, how we can approximate the mode profiles uh, of the fundamental modes using a Gaussian approximation. Um, and that's where we also saw Marcuse's relation and mode field diameter concept. Those were the basic concepts covered this week. And these are not all of the equations, but uh, these are some of the representative equations that would be used to solve problems from this week's content. So these um, critical angle, acceptance angle, numerical aperture, those should be familiar from earlier courses, I hope. And then we didn't go much in depth, but while discussing losses, we saw equation for macro bending loss. Then we went ahead to discuss these modes of a fiber in ray picture. Then what the modes mean in Maxwell's equation, full vectorial method. How we use separation of variable assumption to solve for these partial differential equations. Then this beta is limited by an effective, uh, how it has to lie between, an effective has to lie between the end of the core and the cladding. And then we saw some mode profiles that can be simulated using finite element method, etc. Like there are numerical methods to solve these. You can do those in any software, but there are a lot of commercial softwares like COMSOL, etc. that solve these problems. The plots shown in the class were probably from Lumerical, which is now bought by ANSYS. Their expertise in is in solving these um, numerically solving Maxwell's equations. Then we went to these BV curves. And these we introduced this V number parameter, and then we capped off using this mode field diameter concept and how to find the mode field diameter for a given for this small range of V, that is for single mode field. These are just the concepts that were covered this week. And this week's quiz is based on one MATLAB program. So I think 50% of the questions are from MATLAB. So to run those, I hope you guys have been able to run MATLAB, at least MATLAB online. Uh, so this is the code shared in the Google Drive folder. You can go through this and you're asked to change some parameters in this code. So these two plots will be generated. This and you're expected to change these parameters in LHS and RHS. The plotting part you don't have to worry too much. I hope it's not too difficult. Also, if you're having trouble with MATLAB, you can also run the same program without changing anything in Octave that is free and uh, you can easily get it. You don't need licenses. It's completely free. So that same code will run in Octave also. Like in case you are having trouble with MATLAB. That's pretty much it from my side actually.
So anyone have tried to MATLAB online? I have any issue in during that running the online MATLAB? Have you tried to run the MATLAB online? Any student? Have you run any simple code? You have to try to any MATLAB, and this is very helpful. You are in that as for industry purpose and for academic purpose, that both for you. I asked to you. Anyone can tell me that student? You can mute yourself and please answer that. Have you tried? You face any difficulty?
He Manish this side.
Yeah, Manish, tell.
While going through the assignment, see the content of the week 5 is very useful. Means a lot of equations are there, and to solve means all the equations are there to how to drive the things. But while going through the assignment, see first question is itself. I'm not being able to. I'm not asking any solution for the question number one, but
Okay,
but what is the but how the solution of B is basically N1 and N2 by virtue of which I can find out the numeric radius of the optical fiber. But
okay,
as you know that in a single fiber mode, it is being mentioned that voltage should be lie between 0 to 2.48. But
okay,
in case of option 2, it is asking that what is the value of B for the voltage 4. Point number 4. How is we going to try? And for V equal to what kind of output is required. I mean, find a solution of V where the possible modes means what we have to provide the different kind of modes that is LP or something else.
okay. For assignment number 5, you ask about the question 2,
Question
So
one,
it's not
question
like
1.
if the V number is exceeding 2.4, so it won't be single mode.
absolutely
So yeah, where is the problem in it?
means I'm not being able to ask understand that find the solution of B which corresponds to pollution possible modes. What we have to find out.
You have to plot the transcendental equations and find.
Manish, have you read about that microwave? Any course about regarding that microwave? Manish?
No, no, no.
Actually, whenever we have to solve the Maxwell equation and in the transmission line, like that in the optical fiber is like a transmission line. So in a
Hmm.
microwave we have the transmission line. There is a two mode of the transmission line. It is a we have the that microwave mode. Antenna like that we have the linear polarized, circular polarized, and electrical polarized. So it is
Absolutely
a transfer of the electric mode or transfer of the magnetic mode. We have the
correct,
two mode.
correct. I know
Okay,
that.
so when we have to solve that Maxwell equation in the form of that in the linear polarized mode, like that E equal to E naught cos omega t plus phi plus E naught sin omega t plus phi. In the linear polarized mode, we have both the phase and that amplitude should be the same for that both the wave, both signal. It is so it will be in the constructive mode like that. So it will be not destructive or not cancel to each other like that. In the same
Mhm.
case, we have the optical fiber. So
Means
as
basically
we
the two waves, electro and magnetic waves are basically propagated in x and y directions.
yes, x and y direction. So where we have the one direction is the z direction in which it will affect if the z equal to 0, then we have to in the electrical field we have the magnetic field equal to 0 if the z equal to 0, h z equal to, and in that
Correct.
magnetic field if the ez equal to 0, it means that we have purely magnetic line field, the signal is purely magnetic.
Okay.
Okay, so like that, ma'am is also taught you in the class in the lecture 5 that we have the in the single mode fiber
Correct.
we have the
Correct.
mode
Correct.
like that
Correct.
LP0 that linear polarized mode equal to 0 1 1 1, that is the L or M that component, that is a longitudinal or that M is like that.
Yes.
So
Yes.
we
Yes. Correct.
whatever the we
Correct.
consolidation diagram we have to draw it will show that how much that if the L equal like that LP equal to 0 1 mode, so L equal to 0, then when you have to put L equal to 0 in that equation, V equal to under root 1 minus B square L, some equation is given that. Okay.
Correct.
So whenever you put your L and M value in equal to that, then you have to plot one graph. So it will be like that. The waveform is like that exponentially decay, harmonical distortion. It will be fluctuation in that x and y direction, negative and positive. So you have to answer that what is the that waveform is like that. Is exponential decay, harmonical, it linearly, or whatever that waveform will become. So you can that you can code that in the MATLAB also, that code, and you can send the waveform also that through that equation that, and you can answer that equations also that. You put that equation in the MATLAB
So
and you put
we have to put all these equations into MATLAB to find out the answers.
two
The
equation.
codes are already given.
Yeah, codes are already
Uh,
given by Jonek like.
so on top of the quiz, there is a click here to find the codes. Click here to download the supporting files for solving questions of this assignment. Is
Yes.
given, right? There is a .m file there. You can run it using either MATLAB or Octave if you're having trouble downloading MATLAB or using MATLAB online. You're supposed to solve those transcendental equations, understand the code, and change some parameters there. That's all. Just plot the LHS and RHS, and
You just
uh,
change the value of that L and M value only. And whatever the angle, phase angle, you have to check that, because in the linear polarized, the phase will be same for both.
so the
Manish.
codes are already given. You're
Oh.
supposed to understand how to run those. That's all. What all is the code is doing? Like it's on top of the quiz. I'm sharing my screen.
Yes, Jonek, can you share that so people understand?
Is it visible? This quiz.
Yes, yes.
So just click here. This is accessible everywhere, right? Like I'm logged in through some weird NPTEL. Like this is the file that is given to you. Just download it and you have to try to run it. This code is already given. There is some supporting material also set by previous TAs.
Yes, these both equation are 1 and 2 are Jonek will be solved in MATLAB, I think.
So just download those. They on the first run in on MATLAB, it will produce two plots like this, these, and the same thing you can also try in Octave. That same file I'm running in Octave, it will produce the same things. So you're asked that what is this intersection point? That's all.
Manish,
I hope it's not
understand?
too difficult. Like this quiz was supposed to be very easy, like a breathing room kind of thing.
Manish?
Yeah, understood. Understood now. So we have to basically find out the values by running on the MATLAB.
Yes, yes,
Yeah,
yes.
yeah.
Okay, okay, okay.
Okay, so both the question have you have to got the answer from 1 and 2, both are related that assignment. Anyone else? Sarthak? Sarat? Sarat Kumar? Anything? Any have doubt in this? So either we can proceed and that. Navya?
Sir, am I audible, sir?
Yes, 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 sir.
Okay. Sir, sir, may I know what's the use of this Bessel function in order to find out this? Because if you see a mathematical wise, Bessel function have more computation complexity to solve this because it has more dependent parameters and independent parameters. So
Yes,
what's the
yes.
specific reason to solve this Bessel function, sir?
So
Don't
first we are going for more accurate answer. Ultimately, in practice, we will be approximating these as Gaussian or more familiar functions. Like Bessel functions definition uses this gamma and all these. The definitions itself are themselves are very difficult, right? But that's the answer that comes up when solving these uh, guided modes and these things. So we have just briefly touched it. I don't think we will return to Bessel functions intentionally. Like we will be approximating using Gaussian and these.
Okay, sir.
When explaining these LP01, LP11 modes, where do they come from? They come from this specific form of a differential equation. When you're solving, they appear there. That's the whole point of this exercise.
So,
Okay, sir.
so Sarath, if we have that cylindrical equation and that elliptically or like that equation, in that form we use the Bessel function. That linearly we can
Yes, sir.
solve through that, but if we in the cylindrical and that parameter we can get through the Bessel function like that.
Okay, sir. Sir, in the practical design considerations,
Yeah.
the parameters as given in the problem, based on this L value, it may shifting or it may change. Some parameters may be reflecting in our output, and some parameters may be a dummy parameters. So, how we are going to get the computation for the realistic fiber optics communication, sir?
So in
Uh, you
yes, John.
can run simulations anytime before running experiments. We will run simulations either using MATLAB or for solving these finite element kind of things. That's these kind of computational electromagnetics problems are usually solved using specialized commercial software. Very expensive, of course, but like you can simulate fiber and modes using COMSOL or the next very popular solver these days is Lumerical. It's a part of ANSYS suite, but one license comes for some 17 lakhs or something. So the same things can be solved using MATLAB and Python also, but it's like less friendly to you. Like just getting the structure of a fiber down is very difficult in MATLAB or Python if you're doing everything by yourself. So COMSOL, I hope everyone has heard about that COMSOL and ANSYS and these differential equation solvers. So those are usually the starting points. After that, of course, experiments are the king. Like you have to do experiments, but to predict what the experiment will give you, we usually run simulations.
Okay,
Does
so
that
in the
answer?
MATLAB, is we go for some trial and error method in order to get our outputs in this.
Uh, like these COMSOL or Lumerical, they're designed to just solve differential equations. COMSOL is famous for solving coupled differential equations, like COMSOL multiphysics itself as. So you can solve these Maxwell's equations at the same time. Some heating effect is also coming in. Uh, those kind of simulations are done well in COMSOL. And Lumerical got famous by doing photonics related simulations. So one new field that is coming up is silicon photonics. Silicon has refractive index around 3.47, I think, and silicon dioxide is 1.5, 1.46. So the refractive index contrast is very high, and they are making photonic chips instead of electronic chips. For those kind of simulations, this numerical software is very good for those. Like it's designed for those. The more profiles you saw in class, the ma'am used in slides, right? Those were simulated using numerical. It's Like it's good at
Jonak,
finding more
can we
profiles in this
through do
sense.
the FDDT also that?
Yeah, FDTT also, like numerical can do. COMSOL also, I think, but COMSOL is more. I think I
COMSOL
have
is the
used
mode
COMSOL
regarding
more
the
towards FTM.
material. It will build a mode regarding the material property, like that optical fiber, that how much signal and that will be.
Okay, sir.
Yeah, yeah. For a link design, MATLAB is more than sufficient.
Yes, yes. So, Sarath,
So
you have to consider lot of parameter during that practically, that like that heat dissipation, whatever the ray is going through the cladding, also losses, splicing losses, connector losses. Use the isolator and that converter for that WDM, FDM, everything. You have some losses is there. So for to design the complete fiber link, maybe that we have some lecture on that, one chapter about that also, that in like the 7 or 8 lecture you read about these things in.
Okay, sir. Thank you. Thank you.
like
Namit,
computational electromagnetics is a different course. Like it goes in a very weird direction. We won't be considering ourselves in this course, but of course we'll be using some results. That's it.
anything else? Namita, Navya, Dilkris, Ladli, Kusagra, please unmute and ask your doubt, please. Ramya, Ravi, Navya K. Are you there or you just joined and just left that? So, Jonex, should I continue?
Yeah, sure.
Slide is visible, Jonek?
Yes, yes.
So these are the questions we can discuss in the class. Some basic questions I have put from that lectures. So I need your contribution in this. You can participate and answer that, and whatever the correct answer, I will also that add something if needed. So anyone can explain the Snell's law you have read in your BTech, MTech, or like that.
Yes, so Snell's law, is when the refractive index of two medium, like the core refractive index is N1, which is greater than N2. So
Okay.
at the interface, core cladding interface, N1 sine theta 1 is equal to N2 sine theta 2. This is Snell's law.
Yes. So where we can use this in optical fiber? Any
So
applications?
it is used to understand the phenomena of TIR.
Total internal reflection.
Yes, sir. It is the basic phenomena which is used to understand the mechanism of TIR.
So we can use the Snell's law will maybe come from that physics of that reflection and reflection.
So Snell's law refraction.
No, we have not optical fiber. Whatever the basic optic things that we can read in a 12th. So whatever the ray will become, it will be reflected and reflection. Like that, this is the
Sir,
medium. This is my N1 refractive index N2. And this waveform becomes, some waveform will be transmitted and some waveform will be reflected. This is my theta I, this is my theta T, and this is theta R. So in this case, Snell's law is applicable or not in this case? This is also
is equal.
this is also two medium N1 and N2.
Sir, the ray must light from the higher refractive index to the lower refractive index material.
Okay. So why we need that refractive index of N1 higher than N2? core have the more refractive index than cladding? Why?
So because so that the light will propagate inside the fiber, the TIR will achieve when N1 is greater than N2 and theta 2 should be greater than theta 1. Theta I should be greater than critical angle. Only
Okay.
then, at that condition, the light signal will propagate throughout the core of the fiber.
Okay.
That's why we need it.
Okay. Okay.
The speed of the light changes with respect to refractive index. So when
Okay.
this if it is a refractive index is more, then the speed of the light will decrease. So then the refraction will happen. The
So, what is the? Can you, Namita and anyone, can you tell me that what is the condition for total internal reflection? Any relations?
Yes, sir. Internal incidence angle should be greater than the critical angle. Then only TIR will achieve.
Theta I should be greater than theta C.
Theta C. Yes, sir.
So, like that, I have the optical fiber. Okay. This is my reference line. This is my ray will become. This is my theta I. This is theta T, and this is theta I. Theta C. Okay.
Yes,
So
sir.
what is the value of the theta C that because we have to, like that one condition you have to read that theta T should be less than equal to pi by 2
Pi by
minus
2 minus theta
theta
C.
C. So I have asked about this condition required to for total internal reflection. Which condition will be
Okay, sir.
satisfied at? Because
Yes, sir.
this angle is theta T and this angle should be less than equal to pi by 2, when then it will be theta I should be greater than theta C. Okay, have you understand?
okay.
uh, Next question.
Yes, sir.
Acceptance angle of the optical fiber depends on what is the role of the acceptance angle?
So acceptance angle is the maximum angle to the axis at which light may enter in order to propagate.
Okay, so this is the diagram that theta A should be that maximum should be enter of like that light. Okay, so what is the role of that? Depend on what parameter this depend on? I need a parameter.
Refractive indexes.
Yes,
N1, N2 refractive indexes.
N1 and
N1, N2, and N0.
so can you tell me the formula of acceptance angle? How can we
Yeah, root
calculate?
of N1
Sine
square minus
inverse.
N2 square by N0.
Sine inverse
No,
of
theta.
under root of n1 square minus n2 square divided by n naught.
Okay, so it will depend upon which parameter that sin theta A equal to.
Root of N1 square minus N2 square by N0.
So what is N naught here?
Air medium's refractive index.
Here, and N1 and N2 is the core and cladding.
Core and current refractive.
So if my, sorry, this is my optical fiber. Okay, if this is ray coming and this is my theta A, if ray will be passed through that, in this condition ray will be propagate or not propagate? This is the ray.
It will propagate.
Yeah,
Yeah, it will propagate because the ray is inside the acceptance angle.
and whenever this is my acceptance angle theta A, and when ray will become like that and when they will be
No,
go like that, in
no,
that
it will not
condition,
happen.
why?
It will not happen because the incident angle is more than the accept. It is not in the acceptance angle, so most of the things will escape from the core. Most of the energy of the light will escape from the core because it will not satisfy the critical angle concept.
Okay, so it will not take the total internal reflection in that case.
Yes, yes.
So what should we do that our that incident ray will be come in between that theta A? So what parameter we have to take care during the design of that?
So N1, N2 should be designed.
N1 N2.
No, means we should choose N1, N2 such that the angle is
Angle is like that.
within. No, you need to choose the N1 and N2 values such that the sin theta A is within that
Okay,
uh,
so n1,
angle.
so n1 and n2 is directly proportional to square root that n1 minus s square. Okay, and
Hmm.
surrounding medium is n naught air. It is inversely
Correct.
proportional. So which
Correct.
parameter is more effective? You have to take care of the surrounding medium or that internal that n1 and n2 refractive index.
Sir,
Okay.
internal
Yeah.
N1 and N2.
No.
Okay, so outer environment will not affect that, and not have not impact
Can.
like that not equal to one value. I think that for air
Yes.
is
Yes.
one.
N not even.
Yes, sir,
Hmm.
air is one.
If you dip in the water, it is 1.3 or 1.4 like that.
Correct.
So then in that case, what happen?
Okay. Okay. So then this angle becomes less. Then this acceptance angle will become less if the medium is other
So
than
it
negative.
will also have some significant impact on that
Yes.
sine
Yes.
theta.
Yes. It will have a significant effect.
So we have to take their surrounding medium also. We have to take care of the surrounding medium also that
Yeah.
because it is the
Yes.
fixed parameter. We have to design the optical fiber. We cannot change this parameter.
Okay. 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 So
We have
medium
already
altering.
designed that fiber and we want to now that laser light will go through that fiber.
Yes. Yes.
Whatever in our hand like that we have to take care of the surrounding medium.
Hmm.
Okay, in practically
Yeah.
if you have the if you line of the optic fiber like that in the like in the sea and in the sea you have to take some company will be take the optical fiber cable from the sea and the laser light will be go through that for communication or say transfer of the some signal, then he will take care of that surrounding of the sea, that environment effect, that what of the component of the sea water content, how much that harmful for that optical fiber, life of the optical fiber, how can we take care of that. So this is Manish. You have to reply that answer that like that. It will be reflected through that when theta is greater than theta a. So it will pass through that core and it will go to the cladding also that. So we have the loss of the signal in that case also.
Hmm.
So why we use the numerical aperture in optical fiber? Anyone can?
That
So
is the that.
the numerical aperture shows it's the largest angle in which the rays are accepted towards the fiber.
It is
What?
Sir, the
the
light gathering capacity of optical fiber is determined by the numerical aperture. Gathering
the
capability of an optical fiber.
amount of
Okay.
energy. That amount of energy of a light can be pumped into the fiber cube.
Okay. So capacity of define of that numerical aperture. Uh, So numerical aperture equal to under root square of n1 square minus n2. I am correct is? I am correct or not? Hello?
Light gathering capacity of an optical fiber is determined by numerical aperture.
Okay. So if my diffractive index is equal to that cladding index code, and then what happened that gathering capacity? If my n1 equal to n2, then what is in that case?
The pressure is
Sir, sometimes we write N1 under root 2 del, sometimes we write N2 under root 2 del. Why we are
Yes,
writing like sometimes
del,
N1,
del,
sometimes
del,
N2?
del is equal to n1 minus n2 bata n1. Okay.
Mhm.
So numerical aperture we can form like that. In place of that n1 and n2 we can replace with a del also that. It is a just difference of that medium of one medium to another medium. I think that Jonek, what is it is specified delta?
Yeah, in that case, like n1 square minus n2 square is expanded as n1 plus n2 times n1 minus n2. And n1 plus n2 is approximated as 2 times n1 because they are supposed to be very close. Like that's
So
how that equation comes. Like
so
they're the
what is
same
this
thing.
delta specified Jonek? This delta in the optical I forget that. Something is given that why we have defined this delta. It
I
is
also don't
mode of
remember.
like that mode profile may be shown by thing this.
I also don't remember. Maybe post something on forum. We can
Okay,
get
okay.
back then.
I think it's a reflective index parameter.
No, no, delta have some significance. I forget that delta. I think it will be used for the profile for that, like that step index profile or like that gradient index profile. In that case, we use that whatever the difference like that. We like that this type of the profile that there is a n2 and there is n1, and then in that case we measure that difference through the delta. That I am not correct. I will let you know next class. Maybe I will also define. I forget that. So we can in place of Namita n1 we can pull the delta also in that case also.
Yes, sir.
Okay.
Yes,
So
sir.
next question is the what is the losses, yeah, attenuation in optical fiber? How much the losses, you know that any losses?
Sir, absorption loss, scattering,
Absorption and scattering.
dispersion, radiation, and coupling loss.
Radiation coupling or that. Okay. So what of absorption and radiative? Okay. So what is the absorption losses?
Material absorption losses, silicon dioxide,
Silicon
and
dioxide
OH
is
OH absorption, hydroxyl
okay.
ion absorption.
Okay.
Because actually we had doped the glass fibers with doping materials. So
Okay.
doping materials have their bondings with at a particular resonant frequencies. So if the pumping frequency is in the is having the same resonant frequency of the bondings, so then that particular frequencies will be observed. And since
Okay.
these frequencies are also in the IR range, so we need to take care of those things.
So absorption losses is like that. OH is like that as extrinsic extrinsic doping like that,
Yes,
and like the
OH is
silicon Si2 losses is due to that intrinsic.
yeah, correct. Intrinsic losses. SI because it's a we had to live with SiO2 because that is where
Okay.
the glass fiber will be made.
Okay.
This is a
And
process absorption basically because of
and
process.
so what is radiative losses?
It is basically dispersion and then
How you define radiative losses? Namita, Manish, Ladli.
Yeah.
They're due to Rayleigh scattering and waveguide imperfections.
So scattering means it will ray will be passed through that cladding. It will not go through the clay core. This
Scattering losses are basically wavelength dependent.
so
The power loss
scattering like
occurs.
scatter that power like that, it will not travel through the core and some power will go through the cladding. I am correct or not? Whatever it means, it is the scattering, na? Some power is go through the core, not cladding, so it will lose some power and it will be scattered in the cladding, not travel through the core. So when this scattering will happen, in what cases that if I have the that fiber of the 100 meter and it have not connector, not bending and everything is not between, then there is a happening that radiative losses in that case or not?
Hello.
Yes, 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 please. Who is this? Hello, Namita, Manish, Ladli, Sarath, Ramya. Anyone can answer. If it is wrong, then I will be correct it. We are here for you. That if you not speak, then
Actually,
yes, yes. Tell me.
actually, when the light goes into the cladding, it comes under the radiative loss.
Yes, yes. It is correct. So when will be light will we go through the cladding? If my fiber is 100 meter and it will have not, it is not connected, disconnection, not joined, and everything is not between that. In that case, there
Some
is
part,
yes.
some part of the evanescent field will go into the cladding.
Okay.
So it will come under the radiative loss.
So what type of the radiative loss can you, what type of, can anyone answer that? Basic.
Bending losses,
Yes, bending losses.
macro bending and micro bending losses. And
Yes, micro bending and macro bending. Okay.
The radius at which it's bent.
Yes.
new bending and coupling losses.
Coupling losses, connector, splicing. If
Mm.
you join the two fiber
Slicing.
and if it not connected properly, if you break the
The
fiber,
joint.
okay,
Mm.
and you join this through the splicing or connector, if you not proper matching is that, then there is also some losses in that case. Some light will be travel through that that bending or that connector and that splicing through that.
Mm.
Okay, whenever
Yes.
you whenever you have make the transmission of that optical line, and you make the some bending in some places, there is some joint you have to put, and if there is a mismatch of that fiber, that couple and connector or splicing or whatever the put between isolator circulator, and if their refractive index is not matched, in that case is also, so light is be lost in that case also here. So whatever the
Mm.
input power you have to apply through the laser, and whatever the output power it output side, you measure, it will be have some difference, it will become count as a loss.
Mm.
Okay.
Mm.
So can we minimize the intrinsic loss, or can we try to minimize that extrinsic losses or bending losses? How can we minimize that? Whatever the solution we can do that in that case.
So we can reduce the bending losses by, we have one formula for the radius of curvature.
Okay.
So if we do the correction in that parameter, if we decrease the refractive indexes or the wavelength, because the radius of the radius of the fiber curvature depends on the refractive index and wavelength. If we do some minimization or increase or decrease that parameter, then the bending losses will be reduced.
Okay.
And during the fabrication, extrinsic losses occur due to the OH ions dissolved in the water content, which is done during the fabrication process. If we do the fabrication by using purification techniques, then the extrinsic losses can be reduced, which is occurring due to the OH ions.
So can we minimize that intrinsic losses? Any way can we minimize, or we cannot minimize that intrinsic losses due to the
So
SiO2
intrinsic
glass?
losses, we cannot minimize intrinsic losses, but we can minimize extrinsic losses.
Okay. So okay, okay, good, good, Namita. Anyone else? Manish, Sarath, Ramya, Ladli.
By the way, to decrease this intrinsic losses, there is this new research field. It's still under active development. They are discussing like to remove this scattering by SiO2. They're floating this idea of air core fiber. It's a new research area. So if you're interested, you can look into it.
So in air core fiber, I think we're talking about sir photonic crystal fiber.
Yeah, 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 yeah.
Okay, sir. So yes, in photonic crystal fiber, we have less bending losses. Uh, yes, sir. Okay.
So it is new research area. People are trying to make that intrinsic losses to minimize, because it is more and we cannot handle, because it will be happen during the fabrication only, during that manufacturing on that case. So it is not in our hand. It will be there like that 10 dB or 20 dB. We have to take count of that in that case. So now research work is focused that we have to first minimize that intrinsic losses, so we can replace with some material of that, like that, replace with SiO2 some like that silicon and quartz crystal like that. So if anyone can interested, can look into this field also for their research work and for that.
So which software you are using for the photonic crystal fiber if you are using it?
No, no, I'm not using. I'm not working under this.
Okay, sir. Okay,
You
sir.
can search in India. Many people are professor are working on the research that on that. Even that space to fiber, some that open fiber, whatever connect that the people are working at it.
So we're talking about free space optics.
Yes, free space optics is now it's good topic that free space optics that also that.
Also,
Okay,
I'm
sir.
not working. Okay.
So next question is the mode field diameter and why it is used in optical fiber. We all said that the mode is that LP10, LP11, LM1011. What is the mode field diameter and why it is used in optical fiber? Anyone can answer that?
Sir, it's the width of this intensity profile.
So if my
Yep, yep.
this is the that profile of that laser, in that case, how can you define it?
It means what's the fraction of light which is coupled to the fiber in order to
Okay.
increase the efficiency of this process.
So you want to increase that effective efficiency of that fiber. I'm right.
Operating in the resonant frequency.
Okay. So how can you calculate effective efficiency of light? Any formula that you can know that? So how can you calculate the modes of the fiber in single mode fiber and multi mode fiber? How much the mode will be in the single mode and multi mode? Have you read about the formula that in the class, madam
So
also?
V is equal to 2 pi by lambda a n1 under root of 2 del. If V is greater than 2.4405, normalized frequency is greater than 2.405, then it is working as an multimode. Otherwise, if it is less than, it is working as a single mode fiber, if I'm not wrong.
Yes, and which type of that mode is used? That step type or that graded type in that case?
So step index.
We use the graded index in that case. Have you any knowledge? I think that ma'am use only step index in that case.
Yes, sir. Step index is used. So, sir, just tell me one thing. Like, sir, we have two kinds of rays, Q rays and meridional rays. So, if I
Yeah.
talk about graded index fiber, so in graded index fiber, the profile is the ray is meridional rays or skew rays is propagating in a graded index fiber.
Uh, I think that Jonathan, like that in step index we have like that profile is like that.
Yes,
In
sir.
that
Yes, sir.
graded index we have like that profile.
Yes, sir.
Like that multi-mode fiber that mode field diameter like that only. So we have some one formula I have forget that graded index to calculate that. There is
NO is equal to that one's refractive index profile formula.
no it have some component like that d by a component one we have to calculate in that same or that I in Kaiser it is given that about that first chapter or
Okay,
second
sir.
chapter.
Okay, sir. I'll see. I'll see in Kaiser.
Yes, that they have explained about the if one to calculate that area. I think that Jonek, have you remembered that
Nope.
about that skew ray and meridian ray?
No, no, I
Hello.
have not heard in a long time, so I don't remember.
Okay. Namita, maybe if you not get, then I will next class. I will definitely include this.
So, did you got my answer of that question? How many voice signal can be transmitted through a single optical fiber?
Uh,
I think we should convert it to a running joke or something. Uh, I'll post it on forum, like Google discussion
Okay,
group.
sir. So actually, I'm not unable to get time to even like post on the discussion forum. So that's why, sir, I used to attend this lecture, and I have just asked you in this only.
No, no,
Namita,
I have time today and tomorrow. Like
Namita, have
tomorrow
you
and the day after, I have time. So I'll
Yes,
Nam,
sir.
post myself and answer myself. Like I
Namita, have
remember the
you in a
question.
digital communication? Have you calculated how much signal will be transferred through that in
So
communication?
Sir, but what I had done now, just listen to me, sir, once. Sir, I had taken the bandwidth of optical channel bandwidth is 10 to the power 16 hertz, and
Okay.
I assumed that the voice signal has a frequency of 1 kilohertz. So I divide 10 to the power 16 hertz divided by 1 kilohertz. So according to that, 10 to the power 13 voice signals can be transmitted through a single optical fiber.
Okay.
So
Voice usually requires 8 kilohertz or something.
yes, sir,
So,
Jonathan.
uh, like, yeah, the calculation will be done in similar way. But
Yes,
what are
like
the
that
Sir,
actual
in.
figures?
I think that 10 to the power 13 signals can be transmitted through a single optical fiber. Ideally, it's an approximation from my side.
No, no,
Now I don't know, but
we need to that encoding also. Like that in digital communication, we have like that in a optical channel that we have the capacity of the channel is like 4K.
yes, sir.
Okay, and bandwidth of our channel we have like that 50 hertz or 50 kilohertz like that, and we
Yes,
have
sir.
encoded in the one time signal like that 2 ki power 16 single or 16 single one time like that. Okay,
Yes, sir. Yes,
so
sir.
we have to include that 4K into divide by that signal 2 ki power 16 single like that. And this will become to 2 ki power 2 plus, 12 into like that capacity of channel, and then we have to divide like that in that digital communications.
So, sir, my logic is fine. Now I'm
Your
using it
logic is
on.
fine, but how much signal you have sent one time at that in that optical time also that.
Yes, sir. So, I think 10 to the power 13 signals can be transmitted through a single optical fiber by using WDM technique, which
Yes,
I
WD.
can
Yes, in
find.
that. Yes,
Sir,
Jonathan.
it's based on, I think, either what is the bandwidth, whether it is a narrow or wide, and also based on how they are converting from coaxial or what type of digital audio
Yes,
cable to
yes, yes,
optical digital audio
yes,
cable.
yes. Like that in optical modulation, we have some technique like the on optical on OAN and OAK, like that. This modulation and demodulation, whatever that the WDM used to that why did WDM technology. So whatever the bandwidth of that signal and how much the signal you send one time that it is 16-bit signal, 14-bit signal, or the 64-bit.
Yes, sir. You are right, sir. So I
Okay,
think we have to consider that thing also.
that also because you have to code that signal also that you one by one you have not sent that signal 1001 signal go and that you cannot send that. You have to
Yes,
send
sir.
like that
Yes, sir.
packet type of signal.
So how these signals 10 like 11 how can be transmitted through optical fiber by LP modes only?
Uh,
This will be converted into LP modes and then it is propagating inside the fiber.
like that we have to convert these are the electrical signal.
Yes,
Okay,
sir.
we
Yes,
convert
sir.
we have the converter to electrical to optical converter.
Yes, sir. Laser diode and
Yes,
LEDs.
yes, yes. So it will convert in the form of laser, and this light will be travel through that optical fiber. These are
Yes,
that
sir.
LP1 and LPM. This is electro like that. You have heard that electromagnetic microwave subject
Yes, sir.
in your BTech and MTech.
Yes, sir. Yes, sir.
So in the microwave, how can we signal transfer through that transmission line that coaxial transmission line? We have the cylindrical transmission line, linear transmission line. So we have the two transmission line that electrical and magnetical purely like that. We have that TE and TM, and
Yes, sir.
one is a TEM.
Yes,
That's
sir.
a
TEM.
electromagnetic magnet. So we have the
Yes, sir.
electrical in form. We have like that EX,
X.
EY, EZ. In magnetic field like that, this is E signal, E naught. This is the S signal. We have the X, Y, and Z component. Okay. So if linearly polarized means your signal like that, this is the linear polarized. Okay. If you have circular polarized, this is a circular polarized. Elliptically like that, we elliptically like that, this elliptical signal. So even in a linear polarized signal that your whatever the amplitude of the two signal, if you match that, if you send the two signal parallelly, one is that they both have the amplitude same but they have the same phase also. Only that inverse like that in the cos form, that cos omega 1 to plus cos 2 omega, that in the form that in that if you send is a transfer electrical mode, then your sz component equal to 0. Okay, because your magnetic field is equal to 0 in the z direction. If you send in the magnetic mode field at TM mode, then your Ez equal to 0. There is no electric field. But in the now we have used the TM mode. In both cases we have the Ez equal to Hz equal to 0 in the TM mode. Transmission electromagnetic mode. This is used in the microwave signal where high frequency there is. Like that in that optical fiber we use that transfer electric because it is transfer electron form. We use not the magnetic field in that because we use convert the signal in the electrical form only. Okay, whatever the electrical signal we just convert that in the optical form where we have not magnetic field signal in that. So we use the transverse electrical mode signal. In that case we use only the linear signal. The signal that fiber that through that two signal will become like that, they are linearly that pass through that. They are not cancelled, they are in the constructive form, not destructive form. If the signal will be destructive form, one should be cancelled to another signal and we have got nothing there output side. That's why we use the linearly. If we use the circular polarized where we have the amplitude of the both signal should be different but phase should be the same. One signal amplitude will be like that, this signal, and one should be the increase, but that phase will be same on the both the case. But if we use the elliptical form, then our phase and that amplitude both are the different in that case. And to identify that which phase and which signal it will be maybe destroyed in that case also. So in the optical signal we use the transfer that linear polarized mode only that in that case. Okay.
Yes, sir. Yes, sir.
So if you remember and refresh that Maxwell equation and that transmission line of that microwave, basic microwave or electromagnetic, you can recall and conclude that also through that. Both
Okay,
are the
sir.
same like that in that we have the microwave line, there we have the optical line. Okay.
Yes, sir. Yes,
So
sir.
in
Yes,
that
sir.
we use the calculate the S parameter in that case losses and transmission and reflection. Here we use that how much the refractive index, power loss, and that both are the same things. But we use that for the higher frequency or that microwave frequency is very high frequency and lambda is very less. So we have the require the short wavelength in that case. Line require the short. But in why we use for the optical fiber communications, it can travel the long pellets. We never need a connector splicing in that between, and without losses we can transmit the signal around 100 kilometer one time. But in the microwave case we have to use the repeater after the 40 kilometer. Okay. So
Also, we discussed Alexander modulator last
yes,
time. We said we modulate two complex data streams to the LP01X and its degenerate mode LP01Y. Those are the two polarization multiplex modes. And in LP01 mode, that is the mode profile, right? That is traveling as a sinusoid and then will encode data in the in phase and quadrature components.
yes,
Uh, how to transmit data? How do we achieve our 100 Gbps data speeds? That's 4 times 25 Gbps. That was covered in last week's class lectures, I think.
yes. In last lecture, there that my electrostonic effect they have depend upon that.
Yeah, and what travels is this mode profile
Yes.
travels is
So like that now that Geo use that gigabit fiber that case, so that signal will be go through the fiber. If they use that microwave signal and microwave transmission line, they are the costly and we have the losses of lot of signal in that case. So fiber is the now is the best option for that our communication and transmission of the signal in that case. It have less interference from the surrounding. It have the create a less noise. Signal to noise ratio is very high in the case of the optical fiber compared to the other transmission. Okay. So we have the lot of advantage of that optical fiber, and these are that mode just we have to transfer of the signal through the fiber. So it depend upon our design and our signal that how can we modulate whatever the demodulator we use, and that depend upon the designer that part. Namita, anything
Okay,
else?
sir.
Anything else?
No, sir. No, sir.
Anyone have doubt?
Sir,
As-
regarding this fourth assignment, fourth week of quiz,
okay,
the question number 6 is actually I said in previous lecture.
okay.
Bias voltage at quadrature, swing voltage is sixth question, B pi, but the answer is correct, but it shows that the answer is incorrect, sir.
Can you post that to
Which question is that?
Uh, Sir, as a week fourth,
quiz?
question number 6.
Is
BPSK modulations can be achieved by the correct answer is bias voltage at quadrature, swing voltage V pi, but the both option is given the same options
Yeah, yeah,
i-
yeah. That is some.
mentioned in this.
Yeah, everyone will get marks on that. That will be re-evaluated.
we
So
have already
don't
we have
worry.
already put request to the NPL team. They will be either modify and we can give to that something that.
They won't
Okay.
modify. They will give full marks for that question to everyone.
Yes, yes. So we have to that we next time we have to take care of all the question. We have to. I think I myself will be check and I will inform that NPT and Jonek will be maybe that. So next quiz you maybe not get any error like that questions also. We have to take care of that.
Okay, sir. Thank you.
Okay. So any doubt in the assignment of week 5? Any doubt in that lectures you want to understand or you need some clarifications? Have you any group of that WhatsApp you're connected to that course? Anyone, Namita?
No, sir. I don't create any group for it
No, no,
because I
like
don't have
that.
any.
273 student and the strength is around 25 and 20 student are joining just.
So actually, from my region, I only joined from my university. So I don't know. I think many people are from different places. So I don't think so, sir.
Okay,
So
okay.
even I want to be connect with you using WhatsApp. If you able to share with me, please tell me.
Okay, okay, no problem. But because we are just here for Jonek and me for that, you for help out that you understanding more, you can interact with us because you are instructor will be not here for you that any time for that. So we can ask that your doubt to the if we not know then we can ask to the ma'am also that these are the questions about the student. So he can deliver this during the lecture also so modify that any suggestion that regarding the assignment about doubt reading and anything that this live session is for only for you. If you're not joining then we are just here for that we are joining and finish our work only for but how it is benefit to you it is zero for you also that
So
even you no one have tried to the MATLAB from last three sessions John teach about the MATLAB. It is very useful for that in your future also that if you working in the company for research work for higher education MATLAB is for compulsory component. No one have tried to online MATLAB. I think that no one have done any code. So please get some time and please solve the questions. Please read about these things. If you ask the any question, we are not here that we have know everything and we answer that immediately. In next class we take that questions. So even we are also learn from you something. We can teach you something. Both are where we can improve that things that it is better for you that. So if you have any friend that you know that please convince that please join for 1 hour class so he can also touch that what going on this course and how can we get good marks or that useful for you in that life that course. That optical fiber is very important course nowadays. Whatever that technology are based on only for the optical things. We now that chip is designed on the photonics field. Every component is from CMOS to come to the photonics.
actually, sir, also Geo Fiber is, in yesterday news, I had read that 24, 24 states can be connected by through optical fiber.
So they need that communication chip through the optical fiber only that. They need a
Yes, sir. Yes.
modulator, they need that optical slicing, they need that connector, they need that demodulator, they need that how the signal should be that receive loss power. They need for that. If you not, every component is not get optical fiber based only that. now that even that processor chip is that photonic chip, that in the processor now a photonics component will be included. Intel is working on the photonic chips now, Qualcomm is working on the photonic chips. If you're not joining that lecture live session and if you just for that certificate course, then it's okay for that. There are 273 students and from last 5 live session class we got only 20 students in that. And some students just are joining and that they are left that 1 hour is over and they just finished that. It is for you, or we are arranging that NPL team for you arranging these things. Before there is no such arrangement of the live session and nothing that. Jonek, in 2021 it is there. It is first time that
I think we
Yes, sir, earlier it was not there. I had enrolled in last session course. It is not there.
but now that NPL team that want to interact with the student, they want to that how much student feel that their doubt of regarding course and they want to improve something from you, that only. If you not give the feedback and anything, then how to, we are just going and uploading the video and the assignment is everything job is over that.
I think we're preaching to the choir. Like these 12 people already know. We should talk to the other
Yes,
260.
yeah, I already put the classroom that please join the class. You have to. There is no such bound that there is a number and we have to that like that attendance and that everything. You get something from this class. Anything that is something basic and you that you click on mind in any time that. Yes, we have to see that
Sir, I
video.
joined this course only because of this thing that we have a discussion because sir, we joined and we have many doubts. And thank you so much, sir. You are cooperating too much
We
and you
are
are helping
here.
us to clearing
Yes, we are
that
here
doubt.
for you. That Jonek have so much research work. I have so much research work, but we are spending our time for you only that. And if you're not joining, that 20 student will be come and that for that 1 hour we are the sit and Jonik will be run the code and I will just read assignment and some formula and it's not that interaction and discussion class like that. I need the interaction from the whole class that whatever the silly question you can ask that ask that. We know that we are also that same background that level for you that. So this is that mode field diameter that A that we that 2W0. So first question that some questions so you can solve it that yourself. I think that time is over. Anyone have doubt? Sonek, should we stop or I should continue that?
Oh, I don't mind stopping.
So I have three questions for you. So step index fiber has the following parameter. We have the step index fiber. This is the fiber, and this have the n1 equal to u for 1.48. Okay, and that light, that laser light in wavelength is 850 nanometer. Okay, so this delta is the refracting index profile that okay, I forget that. So it will around 1.5% and the scope diameter of that, this fiber core diameter, this is core and this is cladding. So this is d equal to 80 micrometer. Okay, so you have the questions I have already solved for you. So what is the approximate number of the guided mode? So you have to calculate V. How much the mode will be go through that single mode fiber. So I think that you know everyone have the formula of 2 pi upon lambda A under root n1 square minus n2 square. Okay, so n1 you have to provide already. A you have to calculate that the core diameter. So A is radius of that fiber. So A should be equal to d by 2. Lambda you given 850 nanometer, n1 you given, n2 you delta you have to given. So you just put that value, the delta so n2 equal to 1 minus delta upon n1. Okay, it will become, so you put this value in that n2 place in the place of the n2 and you calculate that how much the modes should be propagated through the single mode fiber. Second question is that if my refractive index profile will be reduced to 10 by 10 times. So delta should be reduced by the 10 times. Then what is the radius of that fiber in that case? So you have to calculate already V So V will be should be same in that case. Your delta should be reduced by 10, delta by 10, and then you have to calculate the radius of that fiber. So this is the question, second questions. What is the maximum core diameter radius? So you use the same formula in that case. Third question is about that the mean optical power launched into optical fiber is the 1.5 milliwatt. So P in that input power is 1.5 milliwatt, and fiber has the attenuation of the 0.5. Attenuation we have to define by that alpha 0.5 dB per kilometer. Determine the length of the fiber. So we have to determine this length of the fiber. So that mean optical power laid output, P output should be upon 2 microwatt. Okay. So you can see that how much loss is in that in case. Your output power will be 2 microwatt, but your supply the input power is 1.5 milliwatt. So that loss will be through that propagation of the light through that fiber only. And this is the attenuation constant of that fiber is 0.5 dB per kilometer. So total loss is given by that 10 log P in by P out. So this is equal to alpha upon L, total loss equal alpha attenuation into length of the fiber. P n you are given, P out you are given, alpha you are given, you just calculate the L from this formula. Okay. One question that asked about that LP01 mode by the that Lalli Kumari on that Google Classroom. So we have to answer that which things will be option is that here. Anyone can answer through that mode of the fiber. If anyone want to answer or have some any idea about regarding this. So we have Jonek explained also two formula, V equal to minus VB V root square B KL minus 1 V root B upon KL V root B if L should be greater than 1. Okay. So we use that mode of fiber, that parameter of LP10, that profile ma'am also told that some profile like that, and we have like that circular profile, and that intensity profile will be destroyed in that case also that. And if L equal to 0, then here we have like that. 1 minute. So if L equal to 0, then our V equal to V root B KL V root B into K0 V root B in that case. So you can largely, if you are there, then you can from these things you can calculate that there is a no azimuthal dependence, two field degeneration due to solution, two-fold degeneration due to X and Y electric field polarizations. So you can calculate through that code that things that also that. So the answer is that one is no azimuthal dependence and one is the two-fold degeneration due to X and Y electric field polarizations. So in the lectures, ma'am have also explained some diagram that through the MATLAB calculation. These are come from the MATLAB. Some circular that intensity and electric field direction they have given that through that. Okay. So any other doubt? Jonek, you want to say anything, or should we finish that?
We can wrap up if there are no doubts. And if there are doubts, just question.
Yeah. So if you have any doubt, I think only 10 people are there. So thank you so much. Please post your doubt on ask questions form on that SWAMP NPTEL portal, and also can you put on that Google Classroom. And I also request everyone, please inform your friend that they can join that next live session on Tuesday. Please, if you know anyone, you have any contact number, please motivate him to join, her to join that class, and please participate in that. If you have any doubt in the MATLAB, you need any code, any solution for that, even for week 1 to week 4, if you have any doubt, then please post us. It is not for that week 5 or week 6, you can ask the previous doubt also with us that. Okay, thank you. Thank you everyone.
Thank you, sir. Thank you so much. Thank you, sir.